Slopes of parallel lines are equal, and this is how I say parallel because I get lazy and I don't want to write P-A-R-A-L-L-E-L. Perpendicular lines. Anyone remember? Mitch, what'd you just say? He said a negative reciprocal, and what the heck does that even mean? Mitch, if I had a slope of 2/3, what would be the negative reciprocal, which means what would be my perpendicular slope to that? Perfect. Let's give ourselves a couple examples. What if I said my original slope was 8? What's my perpendicular slope to 8 then? The negative reciprocal, 1/8. Let's do one more. Negative 1/5. What would that perpendicular slope be? 5. Awesome, you guys. So even when it says negative, it doesn't mean that our answer needs to be negative. Like this answer was positive. It's the negative what you started with. 2 negatives here made that a positive. Good, you guys. Reciprocal, flip it. Good, good, good. Okay, so now I'm curious. Determine whether these graphs are parallel, perpendicular, coinciding. What the heck do you think coinciding means? Coinciding. Toby's going to coincide with an offender in soccer, and that means that they literally are the same person, like clash, right? Coinciding would be the same line. Okay, so what about these first two? Talk to me about their slopes. What's the slope of the first one? Slope of the second one? Are they the same to be parallel? Are they opposite negative reciprocals? They're negative, but they're not reciprocals, right? Are they the exact same line? So what are we going to say? Neither. How about this one? We ready to say what these two are? Do I know what the slope of this one is yet? You only know it once that y is by itself, right? So let's go get that y by itself. Y would equal, you got it. What about this slope? And what about this slope? Same? Opposite reciprocals? I'm just going to, I love this little perpendicular little lingo. If you want to write perp, you can write perp. If you want to write perpendicular, write perpendicular. Some people thought that my last one kind of looked like a rocking chair when I did that. I must have had it a little more swoopy on the bottom. But if you want to use that lingo, you're welcome to. Okay. How about this next one? Do we know the slope of this first one? Careful, slope is always just like, what did we say the slope was right here? We said the slope here was 5. The slope here was -5. So the slope here is 1. Very good. Slope here is 1. Do we know the slope of this one yet? Not yet. Let's go get it. Let's go get y by itself. Are we adding x and subtracting 9 or just adding y? Let's just add y, you guys. Move less things. Now what's my slope? I heard it. -1. Are they the same? Are they negative or opposite of each other? Are they reciprocals? Nice. Okay. What's any number over if it doesn't have a fraction? They're all over 1. So this little 1 is really over 1. This little -1 is really over 1. Is 1 over 1's reciprocal 1 over 1? Yeah. So what are we going to say these two are if I've got a slope of 1 and a slope of -1? Perpendicular. Very good. Boop, boop, boop. Good job, good job. This guy down here, do we know the slope of the first one? 4? Do we know the slope of this one yet? Not yet. Let's go get y by itself. And I know these decimals can be scary, but I build this in during the day just to help us get a little stronger with our mental math. 1.5y equals, let's go subtract that 4.5 over. And I know we might be a little uncomfortable with dividing by 1.5, but I'm going to give us some skills. 6 divided by 1.5. Let's break it down. 1.5 times 2 is how much? 3, right? 1.5 plus 1.5 gets me 3. So 1.5 would go into 6. 4 times. You got it. 4x. And then if this one scares you, you could always just take out the decimals. This is like 45 divided by 15. 15, 30, 45. It goes in 3 times. So 1.5 would go into 4.5 3 times. Plus or minus 3? Minus, yep. What are we going to say about these lines if I got a slope of 4 and a slope of 4? Oh, wait, I just said parallel because I had to look further. Someone said coinciding. Who said coinciding for me? Madeline, you said coinciding because are they literally the same line? Yeah, these ones are coinciding. Getting y by itself. Do you want to subtract 3x or add 4y? You could subtract 3x. I'm going to say people are going to mess it up dividing by a negative 4y. If you mess up with negatives, I might add 4y instead. You're going to get the same answer regardless. But if we subtract 3x, we just have to really be careful about that division. So minus 3x plus 12. Be very careful. Dividing by negative 4. Negative 3 over negative 4. Positive. Very good. Negative over negative is a positive. 12 over negative 4. You got it, Bondi. Thanks. 3/4 x minus 3. How about this guy? What do we want to do first? Add 12y or subtract 9x? Subtract 9x, I heard. All right. Just be careful about these negatives. Let's try this in our head. Negative 9 divided by negative 12. First, just worry about the positive or negative. Negative over a negative is a positive. 9 and 12 have what in common? A 3. So 3 goes into 9. 3 times 3 goes into 12. Beautiful. Then I've got to divide 72. This looks a little sloppy, but that's a negative 12 here. 12, 24, 36, 48, 60, 72. Goes in 6 times. Positive or negative? Negative. So we should say minus 6. So it said determine if they are parallel, coinciding, or neither. Then graph them. What do we think they're going to be, you guys? Parallel because we got 3/4 and 3/4. So I'm going to say parallel. Then I got to go graph them. So we just plugged in our point, and we will find that slope on Monday.